Good day to you all. Today we are having differentiation. Okay, now we are to discuss the concept of differentiation. What do you think is differentiation? Differentiation is the process of finding the rate of change of one quantity with respect to another quantity, usually a constant. Okay, that is why we have in differentiation we have changing y over changing x. Okay, where the y here is the what? Is the dependent quantity or variable, and the x in this case is the independent variable. Okay, so we are going to be using the general method or the general formula for differentiation. If we have, for example, we have x raised to the power n to be equal to y, and we have to find what? Dy over dx, or change in y over change in x. What you need to know here is that the power here will multiply x all raised to the power of that same power minus 1. Okay, then whatever I get is your changing y over changing x, because y here is a dependent variable, y x is the independent variable. Okay, so let's take one example. Another example. If we have x raised to the power of 4 to be y to be equals to this, and we have to find the y over the x, how do we go about it? We know that dy over dx is equals to 4x raised to the power 4 minus 1, which is equal to 4x raised to the power 3. Just using this particular formula. This is the general rule. Okay, this is general rule or the general formula for differentiation. So let's take another example. If we have y to be equal to 6x raised to the power 3 plus 10x raised to the power 2 plus 5. Okay, and you have to find the y over the x. What do you do in this case? Apply this same formula to each term in this equation. So applying it to the first term, we have what? 6, we have 3 multiplied by 6 multiplied by x all raised to the power 3 minus 1, plus the second term. The same thing applies to the second term. 2 times 10 times x raised to the power 2 minus 1. Then differentiation of a constant. In calculus, differentiation of a constant is equal to 0. So you have it as plus 0. Automatically plus 0 doesn't affect the equation. So we now have our dy dx to be equals to what? 3 times 6 will give us 18x. 3 minus 1 will give us 2, plus 2 times 10, 20, times x raised to the power 2 minus 1. 2 minus 1 gives us 1, and no need to write it. So we have it as x into x. So this is the differentiation of this particular equation. So now let's take another example. If you are given this 3 bracket 2 x raised to the power 4 minus x plus 1, have your y to be equal to this, and you have to find the y over the x. Okay, you come here and have it as what? The y over the x will now be equals to 3. You have to expand the bracket. This is what was given. This is what was given. So you expand this bracket by multiplying everything inside the bracket by what is outside the bracket. So you have 3 times 2x raised to the power 4. You now have 3 times 2x raised to the power 4. Yes, minus 3 times x plus 3 times 1. So you now have it as what? 6 rather. 6x raised to the power 4 minus 3x plus 3. So now we now have it as, if we are to differentiate this is not yet differentiated, so it's still our y. Our y equals to this, right? Our y equal to that. So our y equals to the, we are just simplifying. So now to find the differentiation, the y over the x, now we apply the same rule we stated earlier. In this case, where the power here is 4, we multiply it by the term and then subtract the power. So we now have it as 4 times 6. Have it as what? 24. Then s raised to the power 3, because 4 minus 1 from this formula, the power minus 1. So 4 minus 1 gives 3, minus 3. The power here is 1. So 1 times 3 is still 3. Then 1 minus 1 becomes 0. Therefore, anything raised to the power 0 is 1. No need of writing s again, because x is now 1 raised to the power 0. So therefore, we now have it as 3, because 3 multiply 1 will still give us 3. And as I said earlier, the differentiation of a constant is what? Is equal to 0. So you no need of writing it. Therefore, this is the differentiation of this particular thing. So that is that you need to know about the general formula.